Good morning, students. Now, in this video, I will explain the syllabus of first model. Now, this video is for first model. Okay, so this one is already discussed in the classroom, and now I will explain about internal combustion engines. Okay, before that, we have two types here. So that is, in the internal combustion engine we have two types. First one is the CI engine, that is the compression ignition engine, and one more is the spark ignition engine, that is SI engine. Okay, what is the difference between CI engine and SI engine, or a SI engine or CI engine? Okay, see here, either SI or a CI engine are used to obtain motive power to perform various functions in the automobile. Modern automotive engine vary greatly in size and design, but the operating principles are essentially the same as those of first model developed early. Now, in SI engine, spark plug is used, and spark plug is an essential component which initiates the combustion of the fuel. The spark plug produces electric spark of high energy which initiates the ignition of the fuel. In CI engine, the high temperature of compressed air ignites the fuel, and this is called self or auto ignition. The fuel pump and fuel injectors are essential components of CI engine. So likewise, we have two types of engines in the IC engines, that is CI engine and SI engine, and the difference is like that. Here the combustion taken place in the SI engine with the help of what is spark plug, and the combustion taken place in the CI engine is because of the high temperature of compressed air which ignites the fuel. So likewise, we have the difference between the two types. Okay, now what are the different parts of the IC engines, internal combustion engine? So these are also already explained, but once again in the video I can explain here. Okay, with the diagrams and all. Okay, the main components of IC engine, whether it may be CI engine or SI engine. Okay, so these are the main components. First one is the cylinder. You know about the cylinder. This is very important part of the IC engine. And next one is the piston is required here, connecting rod is required, crankshaft is required here, valves and valve actuating mechanisms are required. Means valves are required. So what happens, how the mechanism it is there while operating the valves in the engine. So we will discuss one by one. Okay. Now the first part is cylinder. Cylinder is the main body of an engine in which piston reciprocates to develop power. It has to withstand very high pressure and temperature around 2800 degrees Celsius. A cylinder block is one which houses the engine cylinders. If the cylinder block is block and crankcase are made integral, then the construction is called monoblock. The cylinder material should be such that it should retain strength and higher temperature, should be good conductor of heat, and should be resist rapid wear and tear due to the reciprocating action of the piston. Generally, cast iron is used for heavy duty engine. Alloy steels are also used for cooling water circulation. Passages are provided around the cylinder. Cylinder block is also carried the lubrication oil to various components through the drilled passages. Okay, drilled passages at the lower circulation at the lower end of the block. Here at the lower end of the block, cylinder block, crankcase is made integral with the block. At the top cylinder block is attached with the cylinder head. It houses inlet and outlet valves. Besides, other parts are timing gear, water pump, ignition distributor, flywheel, fuel pump, are also attached to it. The material used for cylinder blocks are grey cast iron and aluminum alloys. Okay, so likewise, the cylinder, it is there which is designed with the help of those materials, and by considering the parameter whatever I discussed. Now the arrangement of cylinder, we have three arrangements. First one is the inline arrangement. So this is the inline arrangement, very simple diagram you are having here. So these are the this is the diagram for inline arrangement 1 2 3 4. So here cylinders are arranged in a single line. So we can say that the here you may observe in this type number of the cylinder is arranged in a line, that is placed side by side vertically with the common crankshaft. In this type reciprocating forces are nearly balanced. So here this one is the crankshaft and these are the cylinders, and which are kept vertically, and those are connected to the crankshaft. So this is what it is, inline cylinder. And the next one, second one is the opposed cylinder type. So this is the opposed cylinder type. So here is the crankshaft, and the two cylinders we have here, that is first cylinder and second cylinder, those are kept opposite to each other. So that's why it is known as what it is, opposite cylinder type. And next one, the V engine. So V engine, so this is the diagram for V engine. So again we are having two engines, two cylinders here, that is first cylinder and second cylinder, which is connected to the crankcase. The V cylinder crankcase, in this type the cylinders are placed with their axis at 60 degree, okay, 60 degree angle. The cylinders are arranged in a two arms of the letter V, so that's why it is known as what it is, V type of cylinder. Now radial engine. So radial engine, so here you may observe the cylinders are arranged around the radius of the crankshaft, so that's why it is known as what it is, the radial engine. We have here, you may observe five what it is, cylinders. So the cylinder should be with the number of cylinder number should be 5 7 9 like this. It should be odd number, so those cylinders should be connected to the crankcase. So this is what it is, the radial cylinder. So this is what it is, the about the cylinder and types of arrangements of the cylinders. Okay, now liners. Okay, next one is the liners. What is liners? Okay, very important here. The liner is nothing but what it is, there is a coating is required inside the cylinder so that we can avoid wear and tear which is taken place because of reciprocating of. Here you may observe the liner, one type of liner diagram. So this is what it is, the liner. So cylinder block, it is there inside the cylinder, there is the liner is provided, means it is like a coating, so that it can avoid the wear which is taken place because of reciprocation of what is the piston inside the cylinder. So here we have two types, that is dry liners and wet liners. So first one is the dry liner. So this is the diagram, it is there here. So this is what it is, dry liner. So you may observe this is what it is, cylinder block, inside they provided that dry liner. Okay, so now what happens, because what happens here in the dry liner, dry liners are quite thin and uses block metal to give full length support. These liners are made in the form of barrel and flange provided at the top. So you may observe here, this is what it is, flange, and so that flange is provided at the top, which keeps the liner in position. It is necessary to machine the liner surface accurately. So accurate liner, what it is, machining is required here. Smooth machining is required here. Why? Because it should be perfectly contact with the cylinder block. By shrinkage, the liner, it is put to the cylinder bore. If the liner is too loose, so that's why that smooth machining is required. The liner is, if at all it is not machined properly, it will be not assembled properly with the cylinder block, so that what happens, poor heat dissipation will be taken place. So between the cylinder wall and liners, so there is a gap. So in that gap, air may be enter. So because of that air, so air is a bad conductor of heat. So that's why what happens, heat will not dissipate properly. So that's why the accurate machining is required for the liner here, and which will be inserted inside the cylinder. So that is what it is, the liner, so that it can avoid wear, as well as it can helps to remove heat from the cylinder. So now next one is the wet liner. Wet liner is pressed into the bore. So block is supported at the top and bottom. Only these liners are make direct contact with the wet. This is what it is, dry liner. Okay, so this is the dry liner. Here also what happens, so cylinder we have here, so you may observe cylinder block and wet liner. So cooling water jacket and packing rings and empty drains. Okay, so this is what it is, the diagram. And here what happens, so the flange and everything same as usual, the arrangement whatever it is there in the dry liner, here wet liner is also we are having. So but the thing is that here water is provided, so that what happens, so water helps to remove heat from the cylinder. So but in the dry liner we are not having any water or any coolant, so it is very difficult to remove heat, but here we can easily remove heat. And here one more advantage of wet liner is, so not accurate machining is required here. So why? Because so water is used, so that we can very easily remove heat with the help of water. So in the dry liner, so that water is not used, where in the wet liner we are using here water as a coolant. And some arrangements they are provided here, that is packing rings, empty drains, drainage. So everything it is there, so that these are used to remove the water. What it is, empty drainage, so these valves are used to remove the water. So like that we are having the wet liner. Okay, this is what it is, two types of liners. So remaining part I will discuss in the next video. Thank you.